Okay, here we go. We have a problem. We want to calculate the length of one part of the graph of a function, and the function is y equals 1/8 of x squared plus 1. So we need to calculate the length of the part of the graph of the function that goes from x equals 1 to x equals 4. I am going to indicate this part of the graph. We need to calculate its length. So what we are going to do is to express first with the symbol L the exact value of the length of this part of the graph of the function. The next step is we are going to divide the interval from 1 to 4 over the x-axis in 3 parts, and each part will have the same size. So the size of each part will be from 1, and the subintervals will be from 1 to 2, 2 to 3, 3 to 4. And now I'm going to indicate the corresponding part for each subinterval on the graph of the function, so that we need to calculate the length of each of these parts, this first part, and then the second one, and then the third. The problem is that we don't have a formula in order to calculate each of these parts. That's why we are going to use a supposition. Let's suppose each part is a straight line. So in order to calculate L sub 1, L sub 2, and L sub 3, these are the exact values of each part, of the length of each part of the graph. Well, we need to calculate the length of each of these diagonals. In order to calculate the length of L1, L2, and L sub 3 approximated, well, we use the Pythagorean theorem. And this is a very easy thing to do. First, we need to calculate the length of each of the cateches. In this case, this horizontal and the vertical, and for the next one, and so on. And in order to calculate this length, we have the formula and the endpoints of each segment of each cathete. So in order to calculate, we use the Pythagorean theorem, and we get the approximated values of L sub 1, L sub 2, and L sub 3. And this is approximated because the graph of the function is not a straight line. We are using the fact that they are quite similar. They look about the same. So we think that the length of the segment of straight line will be approximately equal to the actual length of the part of the graph of the function. And in order to calculate the approximated value of L, the capital L, we just add up all of these results, and we obtain a good approximation of the value of L. Now, the final question is, what can we do to improve the approximation? What do you think? What do you suggest? Okay, that's it.